Hi everyone, today I am going to talk about the second method of combination, that is parallel combinations. In the last video, we have already discussed about the first method of combination, series combination. The second method of combination is called parallel combination. In this connection, n of the resistors are joined together simultaneously like this, where R1, R2 and R3 are the individual resistances connected simultaneously together. Let us complete the circuit and switch it on. Thus the voltages across each resistor remain same. That is, voltage across R1, R2, R3 are always remain same. It is found that the total current I is equal to the sum of the separate currents through each branch of the combinations. That is, total current I is flowing through the circuit and it is split into three different branches in the circuit: I1, I2 and I3. I1 is flowing through the resistance R1 and I2 is flowing through the resistance R2. Also, the I3 is flowing through the resistance R3. Yes, it is given I equal to I1 plus I2 plus I3. On applying Ohm's law, I we can write V upon R. Similarly, I1, I2, I3 as V upon R1, V upon R2 and V upon R3. Or the potential difference V is common factor and we can take it out, and 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Thus, the reciprocal of the equivalent resistance of a group of resistances joined in parallel is equal to the sum of the reciprocals of the individual resistances. That is, 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3, where R is the equivalent resistance of the combinations and R1, R2 and R3 are the individual resistances that connected in the combinations in parallel. Let us go through an example. Again, we can understand more easily how the current and voltages are distributed among the branches of the combinations. Here in this example, three resistors of 10 ohms, 20 ohms and 30 ohms respectively are connected in parallel with a battery of 12 volts. Find A, the current through each resistor, B, the total current in the circuit, and C, the total circuit resistance. We have to find out A, I1, the current flowing through 10 ohm resistance, I2, the current flowing through 20 ohm resistance, and I3, the current flowing through 30 ohm resistance. B, total circuit current I, which is flowing through this circuit. And C, the effective resistance or equivalent resistance of the combinations of these three. On applying Ohm's law, we know that I1 equal to V upon R1. We got the value V is 12 volt and R1 as 10 ohms. We simply put the values here, and which is equal to 1.2 amperes. 1.2 amperes. I1 equal to 1.2 amperes is the current flowing through 10 ohm resistance. Similarly, I2 equal to V upon R2, we simply put the value 12 and 20 ohms, 12 volt upon 20 ohms, which is equal to 0.6 ampere. Now 0.6 ampere is the current flowing through 20 ohm resistance. And also I3 equal to V upon R3, put the value of V and R3, 12 and 30, which is equal to 0.4 amperes. I3 equal to 0.4 amperes, which is the current flowing through the 30 ohm resistors. Now we have to calculate the value of I. Current I flowing through this circuit. Current I flowing through this circuit. The total current is simply given by the sum of the individual currents flowing through the branches. That is I equal to I1 plus I2 plus I3. We simply put the value here as 1.2, 0.6 and 0.4, and the total sum of these three is given by 2.2 amperes. So 2.2 ampere is the current flowing through the circuit of the combination. The last question is, what is the value of R, the effective or the equivalent resistance of the combination? We know that in parallel combinations, reciprocal of the equivalent resistance is equal to the sum of the reciprocal of the individual resistances, which is given by 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. We know the value of R1, R2, R3. We simply put here 10, 20, 30 respectively. Or 1 by R equal to 1 by 10 plus 1 by 20 plus 1 by 30, which is equal to 11 by 60. And simply R, the value of R equal to 5.45 ohms. 5.45 ohms is the equivalent resistance of the circuit. And this is all for today's class.